The variable charge cations I have colored in violet on this periodic table. The fixed charge cations are colored in fuchsia. The nonmetals are in navy. The fixed charge cations, which are in fuchsia, always have a particular charge that they take. The variable charge cations, sometimes they lose 1 electron, sometimes they might lose 2 electrons, or a different variable charge cation might lose 2 electrons sometimes, or maybe 4 electrons sometimes. So, the variable charge cations are going to be lead and tin, which are the two right here. Sometimes when they form cations, they lose 2 electrons, sometimes 4. And then all of these others that are in violet could lose a variable number of electrons. In other words, any of the metals that aren't fixed charge cations are variable charge cations. To name compounds with variable charge cations, if we're given the formula, here's what we need to do. We need to figure out the charge on the cation. Then we need to write the name of the cation. And thirdly, we need to include Roman numerals in parentheses to show the charge on that cation. And then we write the name of the anion. In these first two examples, if we don't realize that iron is a variable charge cation, we'll call this iron oxide, and we'll call this one iron oxide. But they're not the same compound, so they shouldn't have the same name. This is why we need to use this set of naming rules. This is called the stock system of nomenclature, whenever we use Roman numerals, the stock system. And you can see I've shown here on this periodic table that iron, which is used in the first two examples at the bottom of the screen, and copper, which is used in the last two, that both of those are variable charge cations. Let's follow the steps. Figure out the charge on the cation. Now, to do that, I'm going to kind of show my work here, just so you can see how I'm reasoning through this. This has one oxide ion, and the oxide ion is always going to have a 2- charge. You should know that from your periodic table. Therefore, since there's a 1-to-1 ratio, that iron has to have a charge of 2+. So we've done step 1. We've figured out the charge on the cation. Now we're going to write the name of the cation, and we're going to write a Roman numeral to show the charge on that cation. Iron 2, and then lastly, write the name of the anion. This is the oxide ion. Iron 2 oxide. That's how we say that. How about the next one? Well, in the next one, we have 2 iron ions and 3 oxide ions. And I'll go ahead and draw those out so you can kind of see them. There's one oxide ion, right? All oxide ions have a 2- charge. There's the second one, and there's the third one. That's a total of 2 and 2 and 2. That's 6 negative charges, which means the iron has to have a total of 6 positive charges. Well, what number must the iron have for those to equal out? 3. So we're going to call this iron 3 oxide. The Roman numeral is the charge on the cation. The Roman numeral does not indicate how many metal ions there are. Some first-year students look at this Fe2O3 and they just say, oh, iron 2 oxide. There are 2 irons. The Roman numeral represents the charge on each of the metal ions, no matter how many there are. Alright, let's try the next one with copper. Copper with some charge, don't know what it is, but let's find the bromide ion on the periodic table. Bromine, I'm going to point this using my laser pointer, is right there, which gets a 1- charge. Therefore, since there's a 1-to-1 ratio, clearly that copper has to be 1+, and so we say copper 1 bromide. For this example at the bottom, we've got 2 bromide ions. The formula says we have 2. Each one is worth 1-, so how much must this one copper be worth? In order to cancel that out, it must be worth 2+, copper 2 bromide. To find the formula, given the name, we write the symbols for the two types of ions, and then we balance the charges. So in our examples at the bottom of this screen, we're using cobalt and tin. And you can see on the periodic table that cobalt and tin are both variable charge cations. So when we write out the name in English, we have to use a Roman numeral for any variable charge cation. What's the charge on cobalt 3? Well, 3 plus. The chloride ion, I'm going to point it out with my laser pointer, is right there, which means it's going to gain 1 electron to have the same electron configuration as the nearest noble gas. So it's a 1 minus. So I'm going to need 3 of those chloride ions to cancel 1 of the cobalt 3 ions. The next one, we need to know our Roman numerals. That is a 4. Tin 4 plus. The oxide ion is always 2 minus. So what ratio do we need between these? 1 tin and 2 oxygens. The next one is tin 2 oxide. Again, the Roman numeral is the charge on each of the metal ions. Oxide is 2 minus. So what ratio do I have to have with this? Obviously, it's a 1-to-1 ratio. That's how we deal with variable charge cations.